So this is our review that we're using before we take a little mini test on section 7.1 and 7.2. And earlier we looked at graphs of the inverse functions, and this first part is just matching. So I want to match the sine, cosine, and tangent, those inverse functions, to their graphs. The easiest way I can think of to do this is look for the tangent function. The regular tangent function had a domain of all real numbers, or a range of all real numbers. So the domain of this inverse function is going to be all real numbers. And if I look at this, this has a starting point and an ending point between -1 and 1. And so does this one. And on number 2, we can just very lightly see that there are asymptotes here. And this graph would keep going on and on and on. It doesn't start and stop at -1 and +1. So that's how I know that this is the tangent inverse graph. All right, so then I have one of these is sine and one is cosine. And the key thing that I would look for is I know that the point 0, 0 is on the sine graph. All right, so this one does not have point 0, 0, but this one does. So I know that this one is the inverse sine graph. And this one goes between 0 and pi. And back here, sine goes between -pi/2 and +pi/2. That's another key point for the sine graph. But the original cosine graph goes from 0 to pi, and that would be the domain. So the range on this one is from 0 to pi. So this would be the cosine inverse graph. All right, so you just have to be able to decide which one belongs with which. In the next section, it's asking us to find the exact value. So I'm going to refer to a unit circle a lot in this section. So first of all, when I see sine inverse or inverse sine of a number, that means I want to know what angle has sine of 0. All right, so what angle gives me sine of 0? So sine is the second coordinate, because remember it's cosine, then sine. So I'm looking for the second coordinate to be 0. And I have it here at pi, and I have it here at 0. So remember that inverse sine only works from +2 pi to -2 pi. So I have to pick a value that's on this part of the unit circle. So I'm going to use 0. All right, number 5. What angle has a cosine and I should write this a little bit differently. Cosine of what angle is 1? I should write this as sine of what angle is 0. That's a little bit better. So I want to know what angle has a cosine of 1. Say cosine of 1 would be the first coordinate being 1, and that is also 0. How about a sine of -1? So sine of what angle is -1? So I'm looking for the angle. The sine is the second number, and to have a -1 in that second number, I'm going to look at this angle. This angle is 3 pi/2. But remember, I'm looking for sine values between pi and 2 pi. So if you write 3 pi over 2, technically that is the same angle, but because we're working with an inverse function, our sine domain has to be negative pi over 2 to pi over 2. So I want to look for an angle on here. This is the angle, and this would be negative pi over 2. Number 7, I want to know cosine of what angle is negative 1. Cosine is the first one, and negative 1 here is in the first position, so this is pi. Remember, the domain for cosine is from 0 to pi, so this works. This one says tangent of what angle is negative 1. Now remember, tangent is sine over cosine, and it also has a domain of negative pi over 2 to positive pi over 2. So I'm looking on this side, and I have to have the same values divided by each other. Remember, I have tangent is opposite over hypotenuse, or y over x. If I'm looking at my unit circle, the x and y values have to be the same, but one of them has to be negative. So I'm going to look back here, and it would be this angle here, which is 7/4, but 7/4 is not in my domain. I can name that negative 1/4. So my angle is negative 1/4. Number 9, what angle has a sine of square root of 2 over 2? All right, so y coordinate, I'm looking for a positive square root of 2 over 2, and this would be pi over 4. So that angle is pi over 4. Number 10, cosine of what angle is square root of 3 over 2? Okay, so cosine, I'm looking at the top 2 quadrants. I want positive square root of 3 over 2 in the x coordinate, so that would be pi over 6. Number 11, sine of what angle is negative 1/2? Okay, so sine is the second or y coordinate. I want a negative 1/2, and my domain is on this side of the unit circle. So negative 1/2 is here. 11 pi over 6 is my angle, but it's not in my pi over 2 to negative pi over 2 to pi over 2. So I can count this as a negative angle, and this would be negative 1 pi over 6. So I have to write it as negative pi over 6. That's the same value as 11 pi over 6, but it needs to be in that domain. Number 12, tangent of what angle is negative square root of 3? Now on this one, tangent, remember, is sine over cosine, or y over x. Okay, so make a note of that. So I want to look for something where I have a y that has a square root of 3 in it, and it's got to be negative. So here is a y that has a square root of 3 in it, but if it has to be negative, I'm going to look at this angle down here. Negative 3 over 2. Oh, All right, so if I use these two values for y and x, I divide a negative and a positive, and that will give me a negative. So what I have here is I want my y value, which is sine, to have a negative 3 over 2. All right, so this is what I'm looking at. Square root of 3 over 2, and that's negative, divided by 1/2. And if I were to multiply by the reciprocal here, the 2's would cancel, and that would be a negative 3. So this is the angle I'm looking for, and this is 5 pi over 3. That's not in my domain for tangent. 5 pi over 3 is too big, so I'm going to figure out what negative value is this. So if I were to think that this, if it's 2 pi, is 6 pi over 6. 6 pi over 3. So if I have 6 pi over 3, and I take away 1 pi over 3, I have 5 pi over 3. So this is going to be the negative pi over 3 angle. So this is negative pi divided by 3. Next one, I have inverse cosine. So inverse cosine, I'm looking in quadrants 1 and 2. So cosine of what angle is negative square root of 2 over 2. All right, negative square root of 2 over 2 is this angle right here. This is cosine, and that angle is 3 pi over 4. Okay, so basically we're looking at the tangent or the trig function, determining what quadrant should it be in. If it's tangent or sine, this should be in quadrants 1 or quadrants 4. If it's cosine, that domain has to be between 0 and pi, which would be in quadrants 1 and quadrant 2. All right, so then we find the angle that has this coordinate for the trig function we're looking at, and that would be your angle. Number 14, now we're looking for, same type of thing here, cosine of 4 pi over 3. Oh, and we have the inverse cosine of that. So this actually here is my angle and is cosine of 4 pi over 3 in my domain. Or actually we can just look at the angle of 4 pi over 3 and find the cosine of that. So what would that be? Cosine of 4 pi over 3 right here. The cosine is negative 1/2. Cosine is the first value. So this tells me cosine of what angle is negative 1/2. But now we have to look in, now I'm doing the inverse cosine. Cosine has a domain of anything, all real numbers. It's the inverse cosine that has a restricted domain. So now I need to look in quadrants 1 and 2 to find a cosine of negative 1/2. And that would be, first number, these are hard to see, right here. So this would be 2 pi over 3. And if you look, and we talked about this before, I need to reflect that over the x-axis to get back to this number. But I think if you just look at this, find cosine of 4 pi over 3, and you get this value. This value is between 0 and 1, So if I look in quadrants 1 and 2 that have a cosine of -1/2, it would be the angle 2 pi over 3. Number 15. Again, I'm looking for sine of -pi over 3. If I look back here, -pi over 3, if this is 6 pi over 3, -1 pi over 3 would be right here. And the sine of that value is negative square root of 3 over 2. So if now I want to find out the inverse sine of that, what angle has a sine of -3 over 2? I'm looking in quadrants 1 and 4 for a sine of -3 over 2, and that's my same angle, and that's -pi over 3. And this is one where, because this is in my domain, I could have just canceled them out and said, okay, that's -pi over 3. All right, tangent of pi. So pi is actually in my domain for tangent. Okay, remember tangent goes from, oh, no, it's not. So let's look at this. 1 pi is not in this domain for tangent. So if I look at tangent of pi, tangent is sine over cosine, which is 0 over -1. So that's 0. So now I want tangent inverse, or what angle has tangent of 0? So that would be sine over cosine, and that has to be in quadrant 1 or 4. So sine over cosine, 0 over 1 would be 0. So this is 0. Number 17. Now we're going to solve some equations. And before I can look for the angle, I have to get the inverse sine by itself. So I'm going to divide both sides for 4. So I have sine inverse of x equals pi over 4. So to undo this inverse sine, I'm going to sine on both sides. So if I distribute the sign and the inverse sine are going to cancel, and I'm left with x equals sine of pi over 4. And if I look at my unit circle, pi over 4 is here. Sine is square root of 2 over 2. Next one, I need to isolate the inverse sine, so I need to divide by -6. So I have sine inverse of 3x is -pi over 6. So now what I want to do is sine on both sides so that these will cancel out. And I have 3x equals the sine of -pi over 6. -pi over 6 would be 12 pi over 6 minus 1 pi over 6. So this is right here. And the sine of that is -1/2. And now I'm going to divide by 3 or multiply by 1/3. That's the same thing. And this is -1/6. Number 19, let's divide both sides by -4. So I have inverse tangent of x is -pi/4. Now to undo the inverse tangent, I'm going to tangent both sides. So these will cancel. X is tangent of -pi/4. Now I got pi/4 degrees in the negative direction, so that's the same as the 7 pi/4 angle. Tangent would be -√2 over 2 divided by √2 over 2, and this would just be -1. Number 20. This one says to find the inverse, and it doesn't have anything in the denominator about, or in the directions about finding the domain. So we're just going to do the inverse. So remember, this is y, and if I flip my x and y values, I'm going to have x equals cosine of y plus 2 minus 1. And my job now is to solve for y. So I'm going to add 1 to both sides. So x plus 1 is cosine y plus 2. And to get rid of this cosine here, I'm going to do inverse cosine on both sides so that these cancel. So I have inverse cosine of x plus 1, running out of room, equals y plus 2. So really, y is this value, and then I'm going to subtract 2. So I have inverse cosine of x plus 1, keep it in the parentheses here, and then I'm going to add 2 to this side. And I can't combine this with the 1 because this is part of the value that we're finding the inverse cosine of. Okay, after we find that angle, then we're going to add 2 to that. Number 21. This is y. I'm going to isolate, first I'm going to switch. So I have x equals 3 sine 2y plus 1. And I want to get y by itself, so I'm going to divide by 3. And now to undo the sign so I can get y out of there, I'm going to do inverse sine on both sides. So they'll cancel here, and I'll have inverse sine of x over 3 equals 2y plus 1. I'll subtract 1. So inverse sine of x over 3 minus 1 is 2y. So now I have to divide all of this by 2. So I have y equals inverse sine of x divided by 3 minus 1, all of this divided by 2. Okay? So flip x and y, solve for y, and you're going to have to use an inverse trig function to undo the trig function that's there. Number 22. Number 22. Now we're finding the exact value. All right, so the first thing we have to do is work inside. All right, so this, the inverse cosine represents an angle. So whenever we find that angle, then we're going to find the sine of that angle. All right, so what angle has cosine of 1/2? And we're working with cosine, so it's in quadrants 1 and 2. Cosine is the first number, so that would be pi over 3. So pi over 3 is my angle, and now let's find the sine of that. So sine of pi over 3 is square root of 3 over 2. All right, this is my angle. So what angle has sine of negative 1/2? Sine is in quadrants 1 and 4 for inverses. Negative 1/2 in sine would be this angle. If I put it into the correct domain, I'm going to have negative pi over 6. It's still this angle here. So negative pi over 6. And now I'm finding the tangent of pi over 6. So tangent of negative pi over 6. So sine over cosine. I have negative, let's do this, negative 1/2 divided by square root of 3 over 2. So the 2's will cancel. So this gives me negative 1 over square root of 3. And if I rationalize my denominator, I'm going to write it up here, it's going to be negative square root of 3 over 3. All right, number 24. I have inverse sine of negative 1/2. So again, I'm looking at this side, and that's the same thing we had over here. Inverse sine of negative 1/2, so we know that that's negative pi over 6. Now I'm going to find the cotangent of that. Well, this is the same thing. Cotangent is 1 over sine of pi over 6. If I go to negative pi over 6 and I look at the sign, it's negative 1/2. And basically 1 over a fraction, you're just doing the reciprocal, so this would be negative 2. If you're not confident on that, you could do, top number is 1, so you could do 1 over 1 multiply by the reciprocal, which is negative 2 over 1, and that's still negative 2. Number 25. We're finding the inverse tangent of the square root of 3. All right, so tangent, we're working in quadrants 1 and 4. And I want tangent, which is sine over cosine, to be the square root of 3. So I need the square root of 3 to be on top, which that has to be from the sine. So if I look at this angle right here, square root of 3 over 2 divided by 1/2 is the square root of 3. So this is the angle I'm working with, and that's pi over 3. So this angle right here is pi over 3. And I want the secant of that. Well, secant is 1 over cosine of pi over 3. The cosine of pi over 3 is 1/2. So I have 1 over 1/2, which is 2. Okay, I'm looking for an angle, and I know I'm looking for the angle measure because that's what the inverse sine asks us. What angle has a sine of -3/2? So if I'm looking for that has a sine of -3/2, it's the y coordinate, and it has to be in quadrants 1 or 4, -3/2. So this angle, 5/3, is not in my domain, but -1/3 is in my domain. So -1/3, -pi/3, is my angle, and I want the cosine of that. So the cosine of -pi/3, when I'm looking for the cosine of an angle, that domain can be anything. So we're restricted to quadrants when we're finding the inverse sine or inverse trig function. All right, but cosine of -pi/3 is just the first number, which is 1/2. 27, I have cosecant of inverse cosine of -3 square root of 3/2. All right, so this is just an angle again. What angle has a cosine? So if it's inverse, cosine, I'm working in the top two quadrants, and I'm looking for the x coordinate to be -3 square root of 2. So this is 5pi/6. 5pi/6. That's in quadrant 2, so it is in my domain. Now I want the cosecant, which is 1/sine of 5pi/6. Sine of 5pi/6 is 1/2, so this is 1/1/2, which is 2. Okay, hope you're getting the hang of it. We're doing lots of practice here. So I have tangent of 2pi/3, and then the inverse tangent of that angle. So let's see, 2pi/3 is right here. The tangent of that is square root of 3/2 divided by 1/2, -1/2. Square root of 3/2 divided by -1/2. So the 2's are going to cancel, so this is negative square root of 3. Now I want the inverse tangent of negative square root of 3. So because this is the inverse tangent, now I got to work in quadrants 1 and 4. And what angle has tangent of negative square root of 3? So I need a negative, so that's going to be in quadrant 4. And then again, I want my square root of 3/2 divided by a 1/2. Okay, so I'm looking for those values, and that's this angle, which is 5pi/3. Okay, so to get a tangent of an angle to be negative square root of 3, it's the square root of 3/2 for sine. Cosine is 1/2. That's here. The 2's will cancel, so that's negative square root of 3/1. That angle is 5pi/3. Oh, but we should write it as in our domain. So this angle is actually a negative pi/3, because I have to have it between pi/2 and negative pi/2. So this angle right here we would call negative pi/3. That almost got me. Next one, cosine of negative pi over 3. Well, we're working with the same angle. So cosine of that is 1/2. And I want the inverse cosine. What angle would give me a cosine of 1/2? So now I have to look in quadrants 1 and 2, because that's the domain for inverse cosine. So which has a x coordinate of 1/2? And it would be this angle, pi over 3. Sine 7 pi over 6. Okay, so I don't have to worry about my domain here because 7 pi over 6, or sine has a domain of all real numbers. So I just find the angle 7 pi over 6. That's this angle right here. The sine of that is negative 1/2. So this is negative 1/2. And now I want the inverse cosine. When I'm looking for the inverse function for cosine, it has to be in quadrants 1 and 2. So I'm looking for cosine to be negative 1/2 in the top 2 quadrants. So the first number is negative 1/2 right here, and that would be 2 pi over 3. All right. So the last section asks us to draw a picture to find the exact value. So again, when we have the inverse function inside here, this is like saying what angle has cosine equal to 1/3. All right, so this time I'm going to draw a triangle. All right, so I'm going to draw a triangle, and cosine is in quadrants 1 and 2, and this is a positive number, so cosine of a positive number has to be in quadrant 1. If it were in quadrant 2, cosine would be negative. All right, cosine is it's adjacent over hypotenuse. Adjacent over hypotenuse. The top number is the adjacent number. The hypotenuse is 3. Okay, so here I have a triangle. This angle has cosine of 1/3. Now, this angle we're finding the tangent of. So now I need opposite and adjacent. So I can find this value, which is the y value, by saying x squared plus y squared equals 3 squared. So 1 squared plus y squared equals 3 squared. Oh, there we go. So this is 9. I'm going to subtract 1, so I get y squared equals 8, and y is 2 square root of 2. So this value right here, 2 square root of 2. So tangent of my angle is opposite, which is 2 square root of 2, over hypotenuse, which is 3. All right, next one. I want to find an angle where the sine is the square root of 2/3, and then I want to find the cosine of that angle. So here I have sine, and this is a positive value. Sine is positive in quadrants 1 and 4, I think. Nope, 1 and 2. So here's my triangle. We're going to work in quadrant 1 if this is positive. So this is my angle. I have my angle. The sine is opposite over hypotenuse. So the side opposite is square root of 2. This is 3, and this is x. So I have x squared plus y squared, which is 2, equals 3 squared, which is 9. Subtract 2, I get 7. So x is the square root of 7. So this is square root of 7. Cosine of this same angle is going to be adjacent, which is square root of 7, over the hypotenuse, which is 3. Now I have tangent of some angle is -2. All right, I'm just looking at my angle right here. So what angle has a tangent of -2? Now inverse tangent, I'm working in quadrants 1 and 4. So if I were to draw this angle, tangent is positive in quadrant 1, it's negative in quadrant 4. So that's where I'm going to be working, in quadrant 4. Here's my right angle right here. This is the angle that I'm saying is theta. So tangent is opposite over adjacent. I can make that a ratio. So the side opposite of my angle is 2, and that would be -2. My side adjacent is 1. And that makes sense with the negatives. This is a positive 1, and this is down, that's -2. Now to find the cosecant of this, cosecant is 1 over sine of that angle. Well, to find sine, I need opposite over hypotenuse. So I need to find this value here. So this is 1 squared plus -2 squared equals c squared. This is 1 plus 4, so that's 5. And c is the square root of 5. So this value is the square root of 5. For the cosecant, I'm looking for the sine. I have 1 over sine of, so sine is opposite, which is -2, over square root of 5. So 1 over a fraction is just the reciprocal. So this is square root of 5 over 2, and it's negative. Almost done. Number 34, we have a cosine of an angle, and it's negative. So inverse cosine only works in quadrants 1 and 2, and cosine is positive in, if we think of this, all students take calculus. I'm working in quadrants 1 and 2. Cosine is positive here. Sine is positive, but cosine is negative. So this is where my angle is going to be. Draw a right angle here. Sorry. There's my right angle. This is the angle in question. That's theta. The side opposite, cosine is adjacent over hypotenuse. The side adjacent is negative square root of 3, and that is in the negative direction. And the hypotenuse is 3. And now I need to find this y value. All right, so Pythagorean theorem, negative square root of 3 squared plus y squared is 3 squared. So this is 3 plus y squared is 9. Y squared is the square root of 6, or y is the square root of 6. All right, so 9 minus 3 is 6, then take the square root. So this is square root of 6 on this side. Cotangent of this same angle. Now I know all the sides. Now I can find cotangent, which is 1 over tangent. of that angle. Tangent is the side opposite over the side adjacent. So I have the square root of 6 divided by the square root of negative square root of 3. So if I do the reciprocal 1 over that value, I have negative square root of 3 over square root of 6. And believe it or not, I can reduce this because this is square root of 3. On the bottom, I have square root of 3 times the square root of 2. And the square roots can cancel. So this is a 1. So I'm left with negative 1/2. Negative 1 over square root of 2. And lastly, I can rationalize that denominator. So I multiply the square root of 2 on both top and bottom. So this is negative square root of 2 over 2. And number 35. Tangent of my angle is 1/2. So tangent is positive in quadrants 1 and 4, or 1 and 3, but because I'm working with inverse tangent, I can only work in quadrants 1 and 4. So I have to have a positive angle in quadrant 1. There's my angle, opposite over adjacent. So this is 1, this is 2. So 1 squared plus 2 squared is c squared. 1 plus 4, that's 5. So this side is the square root of 5. And I'm looking for the cosecant, which is the reciprocal of sine. 1 over sine of the angle. So sine is opposite over hypotenuse. So I have 1 over square root of 5. So this is the reciprocal of 1 over square root of 5, which is just the square root of 5. All right, so I hope that has answered your questions through the practice, and we should be ready now to take this mini test.